I have this really good idea for an app that will improve the world so much and it will make me a tech billionaire in the process. I will code it up. Nice. I really like this part about programming when you just have this idea and you can implement it and you can just make it reality. I almost feel like a god or something. Alright, I'm nearly done here. Let's compile this stuff. Shit. It's broken. God damn it. I'm not sure why. Oh well, the ups and downs of programming. Sometimes I feel really, really good because I can have really vague and creative ideas and then build something from scratch. And sometimes it's so frustrating because things just don't work and debugging them is so difficult. Debugging is actually one of the hardest things when you do programming. And there's also really no way around it. You have to put in the time in the trenches. You have to get a lot of experience to get some intuition to get better at debugging. The thing though is, in all my years of programming, I think there is a theory behind debugging, and I can tell you about a system that will help you a lot with debugging your most heinous bugs. I think there's a spectrum of difficulty with really easy and hellishly difficult to fix bugs. So on the one end, the really easy ones, one way to avoid bugs in the first place is to confirm every change you do. So basically you write code and the codes are like fragments that you compose with each other. And as you go along and write your code, you then continuously run your code to test if it actually works. The effort of running code is really low, but the risk that if you don't do it and you write a bunch of code, it doesn't work, what can you do then? There's not really much you can do. You have to go back in time, undo all your work until you find the culprit. So it's really good to always do that in the first place. And herein comes the easiest to find bug, which is that you're already half expecting a bug to appear. You run your line of code, a bug appears, and you have a pretty good idea what the problem is. Next up, there are thinking flaws. So you might think the code runs a certain way, but the computer actually understands it a different way, and there's a mismatch there. One good example here would be getting the last index of an array by using array.length at the index. And since array start at 0, this will not match. And this is counterintuitive, but how computers work. And so once you get your head around that, you can fix the bug. Next up, there are weird effects in the system that you build. So you might build some multiplayer game with scores and attack damage and health and whatnot. So you have different things interacting with each other, and there might be weird interplay that you didn't anticipate that makes sense once you really understand it, but intuitively that you didn't really fully grasp. And there might be some bugs along those lines or ways, and you really have to understand the system well to fix them. Next up, I would say, are sort of the problems you encounter when you have to work with a complicated system. For example, let's say you're building a React application, and then things behave a bit wonky and you have to debug it. And in order to understand the system, you have to really understand React well, how the rendering works, how the maybe use effect hook exactly works, how the interplay between these different React components really is. For example, in my most current quiz app, I have a bug that I have yet to fix where I have to learn more about React. On my first render of the page, there's a countdown bar and it goes down, and then after some seconds, 2 or 3 seconds, it restarts from the top. But this is only for the first render, and then this only happens once and it doesn't happen again. And at the end, the really difficult bugs, I would say, they are when you have no error message or a really vague error message and you really have no clue what to do about it. So how do we fix these kind of bugs? What do they all have in common? Well, let's compare them with the scientific method or scientific endeavor. There you have a theory, an explanation of how things work. You don't know if this theory is true. To find out if it's true, you come up with as many hypotheses as possible that you can experiment on, that you can either verify or falsify. So if you run these experiments and you can verify the hypotheses, this doesn't actually verify your theory, it just makes it stronger. But if you can falsify hypotheses, then you falsify the entire theory. You have to adjust the theory and then generate a lot of hypotheses again. And you have a loop there, basically. You do this until you can no longer come up with hypotheses that manage to falsify the theory. And so debugging is very similar. Your understanding on how the code works is wrong. So you need to come up with a better theory and hypotheses that confirm this theory. Maybe after understanding the code a little bit, you think that some variable is probably null and this is why it's not working. So that's your hypothesis. You run an experiment by console logging it. You see that the variable is indeed null. This confirms your hypothesis and theory. You fix the bug, you live a happy life, everything is good. However, if this doesn't work, then you have to think again. And I would call this the step 1 or the loop 1, the deep dive. If this doesn't work, you have to take a step back and do something like a step 2. In this step 2, you have to first find out where the error is. If there's no error message, you have to progressively comment out the code to find if it works again, or you have to travel back in time by checking out the different commits. And these hopefully should allow you to find the part that is broken. Now that you know what's broken, you can start theorizing. You can start theorizing as the code as a whole, not about the particular reason why it's failing. You build up the theory. So in step 1, you might have a completely black hole of knowledge about the code base, because it's a new code base maybe, and there is a sensory overload. So you have to scout out the code and see what might cause problems and what might be relevant and what might not be relevant. In this process, you gain fragments of knowledge and you have to make many assumptions. However, making assumptions is good because it's very energy efficient. And because there's often information overload, it would be very inefficient to really truly understand everything. This is where your intuition comes in really handy. Once we think a fragment of knowledge or of code is responsible for the problem, we can do a deep dive, or the step 1, the thing I talked about just now. And if that doesn't yield the desired result, we basically have to cycle between these two steps or loops. You basically have to assign probabilities to which fragments of the code are causing the problem, and assign sort of probabilities where the return of investment is the highest. If you don't succeed with this, it's a really good idea to take another step back by maybe taking a shower or going for a walk and thinking about the problem more subconsciously. This will help tremendously with finding maybe blind spots or something you didn't think about. And by that point, you should be able to have solved the problem. So this is basically the systemization of debugging. Another really helpful tool that is often talked about is writing or doing test-driven development, or writing tests in general. Tests are good. I would say oftentimes people don't write tests about every use case, and that's great. The problem with something like test-driven development, where you write a test before you write the code and you try to write very detailed tests, is that if you work outside your comfort zone, you code incrementally and you reevaluate things, and this will make the test that you've written obsolete all the time. But you can do test-driven development at your own discretion. What do you think about this problem? Feel free to write a comment discussing this. I hope you found this interesting and helpful. I hope you have a really nice day.